Hi, today I'm talking about 6.1 graphing systems of equations. Graphing systems of equations is just like regular equations, graphing and slope-intercept. The only difference is there's going to be more than one. So you can classify a system of equations three different ways. If there are, right here, if two lines intersect each other at one point, it's considered consistent independent. If they're parallel lines and they never touch, the answer is no solution because they're inconsistent. So your answer, your actual solution when you're talking about a system of equations is where those two lines intersect. So if they never intersect in parallel lines, you're not going to have an answer. If they intersect right here, this point right here where they intersect would be your answer. If you end up having two different equations and they simplify and they end up giving you the same line, it would be the same line on top of itself, so you would have an infinite amount of solutions, and that is considered consistent dependent. So again, if you have one solution, it's consistent independent. If you have no solutions with parallel lines, it's inconsistent. And if you have an infinite amount of solutions because it's the same line on top of itself, it's consistent dependent. But you solve these the same way that you would any line. So for instance, let's go to the next slide and see. So in this problem, we have y equals 2x plus 3 is one of our equations, and the next equation is 8x minus 4y equals negative 12. Well, the first thing I want to do is put both of these equations in slope-intercept. The first one already is. The second one, we have to get it in the form y equals mx plus b, which is slope-intercept. So to do that, I'm going to subtract this 8x from both sides, and I would get negative 4y equals negative 8x minus 12. Then I'm going to divide both sides by negative 4. When I do, I get y equals negative 8 divided by negative 4 is a positive 2x. Then negative 12 divided by negative 4 is positive 3. So as you can see, I want you to look at this really close because in the beginning, I said that we're going to graph this line. That was my original equation. The second equation I got is this. Do you see something? They're both the exact same thing. So let's graph it. We're going to go to y-intercept of 3, and then you go up 2 over 1, up 2 over 1. And you can keep doing that. This is an equation, so it's going to be a straight line. And that's it. Now, because it's the same line, if I told you to classify it, it would be considered consistent dependent. And the reason that I tell my students this is because the two lines literally depend on each other.